All right, class, today we're going to talk about solving linear equations, which is section 3.1. This is how we're going to go through it. We're going to start with an overview of linear equations, then we're going to solve linear equations in standard form, and finally we're going to solve linear equations that are in non-standard form. So like I said, this is section 3.1. We're starting on page 126. Just so you guys know, we are going to learn to solve linear equations. This is just basic algebra that you've probably seen before, you know how to do, but we're going to put words to it and we're going to find a specific process on how to solve the linear equations. First thing we're going to do is we're going to review a little bit. So we started talking about the rules of algebra, basically what makes something algebra versus arithmetic. We said that for something to be algebra, there needed to be variables. When there are variables, you find coefficients. You also find some constants in those equations or expressions depending on what you're looking at. We talked about the properties of algebra. These are going to be your commutative, associative, distributive, identity, and inverse property. So make sure that you look over those again so that you know what is acceptable and what is not, especially when it comes to solving linear equations. You need to have those down packed. Finally, we talked a little bit about equations. So we talked about the difference between expressions and equations, and you know that it's just going to be that equal sign, and how you deal with each one is going to be that basically if it's an equation, you're going to go ahead and you're going to solve for the variable. If it's an expression, you're basically just going to be doing what you're told. And then finally, we talked about simplifying algebraic expressions, which basically we just went ahead and combined like terms, and we simplified as much as we could. We reduced everything that we could, and we were able to simplify algebraic expressions. So that was previously. Now we're going to start talking about linear equations. So the first thing I want to talk to you guys about is the definition of linear equations, which is found on page 126. So if you look on page 126, you can find this definition. And basically all it is a first degree equation, which means that it is to the power of 1. So anytime you have an equation, that equation is going to have a degree. That degree is just specified by the power, by the largest power that you see there. Okay, so in this case, a linear equation is always going to have a variable to the power of 1. That's going to be the largest power that you see there, the largest exponent. It's a first degree equation that can be written in the standard form, ax plus b equals 0. Okay, so remember this is your standard form. This is only acceptable when x is your variable, right? So if it's a first degree equation and I'm saying that it's x to the power of 1, that means obviously that x is my variable, and a and b have to be real numbers, and a cannot equal 0. Okay, so basically this coefficient here has to be a real number, not an imaginary number, and this one right here has to be a real number as well. This would be a constant. Now you can have a linear equation with a different variable, right? That's totally fine, but in the sense of this example right here, that's just saying that when x is my variable, this is going to be your standard equation. If y were my variable, then the standard equation would have a y here in place of the x. Let's talk a little bit about the different forms of linear equations that you see. Make sure that you're writing these down in your notes. So the forms of linear equations, you have the first one is going to be the standard form, okay, and that is ax plus b equals 0. That's the standard form. Now remember that the a's and b's can be basically any constant that you find, right? So any real number. The second type of linear equation is going to be a slope-intercept form. Now this is probably the one that you're most familiar with because it's the one that you use most commonly for graphing, okay? And it's the one that you're probably most familiar with. So just remember that y equals mx plus b. And the third one is your point slope form, which is y minus y1 equals m times x minus x1. The point slope form is also really, really important when it comes to graphing. It's how we're able to create a graph from just a point that you have if you know the slope. Sometimes you have to find the slope as well. In this section, in 3.1, we're going to be dealing with the standard form the most, okay? But I will be asking you guys to change equations into slope-intercept form as well. We'll deal with point-slope form a little bit later on. So here's some examples of some linear equations. All right, so here you have 2x equals 0, right? And you can see how these are different from linear or from algebraic expressions. One, because you have the equal sign. And in this case here, you don't really have... you're not really told what to do. You have to figure out what to do. In this case, you're going to solve for the x. That's the difference between an expression and an equation. Okay, so here you have x over 2 minus 7 equals 0. You would solve for this x by using algebra, right? You would move the 7 and then multiply by 2 and then cancel everything out so that you're just left with the x equaling something on the other side. And we're going to get into that in the next section, in the next video. Here you have a linear equation in the slope-intercept form, y equals 4x plus 18. Here you see that y, that m is going to be the 4. Here you have your x, and then here 18, you have the b. And then you have y minus 6 equals 1/3 x minus 2. That's going to be in the point slope form. So make sure you have these notes written down. In the next video, we're going to go ahead and actually solve them.